So machine learning models, that is k nearest neighbor and support vector machine, and third one is neural networks. So these are the three types of machine learning models that you need to know. So k nearest neighbors is supervised. So first of all, the keyword is this is a supervised machine learning model and used to uh, which were the two supervised learning models that we talked this last time. Like we under supervised, you were doing two things. One was classification and another one was regression. So for with KNN, what you do, you try to classify or predict the value of the target. When I say target, that is dependent variable. And KNN implementation involves K value. This I'll demonstrate what I mean that. And then identifying closest K observation to point that is being to predicted. Now from this onwards, I'll just try to demonstrate it with using example. Otherwise, it will like you may not follow that intuitively. Just allow me a moment and let me open the example. So we want to predict the new loan application, whether it will default or no default based on the historical data. So say your historical data or training data set is this one, wherein you have got income in thousands dollars, say $50,000 for this A1, and loan amount. What is the loan amount being requested? And this is a credit history. So yeah, and this was a combination, you had default, no default over here. If you see that the credit history was good, income was good, loan amount was also like the loan amount was higher, that's why there was a default. So this is your training data. Now say for example you have got new application and you want to predict based on this historical data, you want to predict that whether your new loan application will default or not using the KNN model. So what you do, you try to calculate. So you take k is equal to 3. You take k is equal to 3 and so this one is choice. Usually what is done, whatever your number of training data is, say for example over here we had 5, so it is square root of 5, which is like this is in fact your point in our slide, number of training data, square root of that is usually chosen as your k value. So k value largely impact your decision. And how do you do now? Like you calculate the distance. So whatever is your new income, like the new set that you're interested in, and what was your in your training data set. So for first 3 training data set, we will calculate this. So whatever was your new loan application, we will compare this with the 3 training data sets. Of course, we will calculate it for all 5, but because our k is equal to 3, the distance that we consider would be only for 3 observations. So let's see. So what we do, like with this one is from the new application, and this one was, so if you see like 65 here, just use this one only. Yeah, this one is pretty easier. Yeah, so when you do like over here it is 65, and if you go down further, we are taken 65 here, and from the training data set we had 50 here, so we have taken 50 here. Likewise for other variables like loan amount and credit history. So you take we are calculating the Euclidean distance, if you recollect from our earlier class. So Euclidean distance is 20.6 here for distance to A2 for the new point that you are interested in, and to the second point in your training data set. So you calculate this Euclidean distance for all, because you are interested in 3 nearest neighbors. You will take first, so this distance, so what you do, you calculate this, all the distances, arrange it in a ascending order. So if you see the 20.6 is taken as 1, 31.6 is taken as second data points, and the third point is 43. For with these, so whenever these were there, say for example, it was first, second, and third. So if I go to my original data set, first, second, and which was that the second last, 43, first, second, and second last. So first, second, and second last, there was no default. So in eventually what you conclude that for the new loan application, you will not have a default. Did you follow or any doubts so far?
Can you just repeat it again?
Sure. Till Euclidean distance, did you follow, Pooja? Like till Euclidean distance, all good? Like how did I calculate the Euclidean distance to these 5 points, or you need the clarification here also?
No, I followed till that.
Okay, so once you calculate the Euclidean distance, what you need to do, you have to arrange this Euclidean distance in ascending order. So this 20.6, it was coming from first A1, and this 43 also. So these, so when you had 50, 25, and 700. So when you had 50, 25, and 700, your distance was lowest. With the new application to A1, the lowest distance was 20.6, that you have kept at 1. And the second highest distance, or the second second in the order, would be 31. Like these are further higher. So 31.6 would be a second data point, and this 43 would be your third data point. Basically, you are arranging in an ascending order the distance that you calculated. And for these distance, so this was your point. So this is your first data point in your training set. This is your second data point in your training set, and this is your fourth data point in your training set. So A1, A4, sorry, this one is this one is 4 data points. So A1, A4, because 31.6 distance is second, but this was a 4th data point in my original data set. And this one is A2. This is your training data set. So A1, A4, A2 is something that you will give input to the model. So when you give input, what model notices is for A1, there was no default. For A4, there was no default. And for A2 also, there was no default. So, and you took k is equal to 3. So the ascending order that you will do is still third data point. Had my k been 4 or 5, I will go further. But in this case, I have taken k as 3. So I will do ascending ordering till the third data point. And because in training data set, for these data point, there was no default, I will conclude that for new prediction that I have, new role application I have, there would be no default. Is it making sense, Pooja? All good?
Yeah.
Vipin, Dacosta, Cecilia?
Yeah. So have we covered the k value here?
Yeah, k is 3 because
K here, right? So whatever the k we will set it, based on that it will start allocate that first, I think, point out that 3 data points, and based on that it will start calculating and the Euclidean.
Perfect.
Right?
Perfect. Yeah, perfect. Yeah, Dacosta, any doubt? I think you were saying something.
No, I said it was okay. But
Great.
then just to clarify, we did the calculation for 5, but we only recorded that 3, which means that's the one with no defaults, which we just continued with the ones with no defaults.
Yeah. And Cecilia, what about you? All clear?
Yeah, I think I had the same question as Dacosta. Then I realized you spoke about sorting in ascending order, and then I realized that the A1, A4 is just the sorting of the top, the 5 in ascending order, and then you pick the first 3.
Yeah, because my k is 3, and depending on the value of k, you will have like the conclusion data, you can say, or the conclusion data points for your final conclusion. So that anyone like out of interest, one would have asked that, so what would have been the conclusion had this A4 been default in my training data set? does it question make sense? Like, can anyone tell me what would be my conclusion hypothetically had my A4 been default in my original training data set? So my question is, like, for example, over here it was quite straightforward because your all three data points were no default. You immediately concluded that your new application won't default. But my question is, had this A4 been default, can you tell me what would have been the situation or any general thoughts? Ideally, this question should have came to your mind, but yeah, like start thinking in that way. Does this question make sense first of all?
Yeah.
Is question making sense? Yeah. So is the question clear? First of all, let me then address. Vipin, D'Costa, Cecilia, is the question clear?
The question is clear.
No, not to me.
So Vipin,
So,
yeah, go on. Was it Cecilia, Pooja? Who was that?
no, I think the question is clear from my side. So it's
Okay.
just to really say that of those two or the top three with the lowest distance, what if one of them, the default was a yes?
Perfect. Yeah, that's the area under discussion. That's correct. So Vipin, our point was discussion was from our training data set, these all three were 0. There was no default. What if, how will I conclude for new application, had one of these three rows was 1 that is default in my original data set, that is training data set? What was my final conclusion? That how would I have concluded for new application? That is question. So is question clear to you? Then I can address like how we do about it.
So how can I conclude like that is default or not, right? That is what we are trying to predict.
Like, see, your prediction is for new application, right? But my point is, when you arrange these training data from your original data set, if hypothetically, if one of this would have been default in your training data set, how would you conclude for a new new application? I will answer that, but is the question clear what we are discussing? Like that,
right? Yeah.
Okay. So how will you conclude about new application is you will then conclude what is the maximum, is the number of 0 appearing maximum time, or is the 1 appearing maximum number of time? So still, had this been 1, still I have 2 0, still I will end up concluding that the new application will not default. Is it making sense? Or there is some probability, you can say like 33% probability is that it may default, or like largely because we go with the maximum probability, you will say that 66% probability is there that it will not default, but there is a 33% probability that it may default. Is it clear? But final conclusion would be no default because we go with the major one. But as a practical manager, you should know that there is some element which may drive this new application towards default. We cannot deny that possibility, but largely you may go ahead that new application will not default. Is it making sense? All clear? Like there are 2 zeros, 0 appearing 2 times and 1 appearing 1 times. Largely we go with this, there is no default, but there is some possibility, like your final conclusion would be no default still if you want to go with the binary model 0 and 1. But as a credit risk manager, you need to be careful that there is some element, the probability is there, which you can further account somewhere. You may charge higher interest rate to some extent or to some adjustment in your pricing. Are we clear? Shall we move ahead? Yes, no?
Yes, we can move ahead.
Okay. Pooja, clear? And D'Costa, Pipin, any thoughts?
So can I ask a question?
Please.
Where we said, let's set k equals to 3k. Could we set k equals to something else? Like,
yeah, that I'll cover in slides. There is one like the provision, like how do you choose the value of k? So there is a proper like the practice or thumb rule that is being followed. So yeah. All good, Vipin, D'Costa and Pooja?
Yeah.
Okay,
Yeah.
cool.
So just a quick one too. So if K was, say, K is 2,
Hmm.
yeah,
So
how would
case
we have?
two, yeah, case two, you will just take first to lowest value. So only 20.6 and 31.6, and both were still zero. Still, we would have concluded that for new application, your it would be zero. Your new application will not default.
Yeah, you said we would have used the lowest one. That's after calculating the Euclidean distance.
Yeah, that's correct. So 20.6 is the lowest, and the next second lowest is 31.6. So if I had my k being 2, this third row will drop, the only two rows will remain, and those are still no default. So for new application that I have, that is A6, I would still conclude this A6, I'll still conclude that that will not default.
All right, sure.
Okay. So this was about KNN. Let's go back to. So, like we discussed in detail. So, when predicting target value, let me just okay, recording started. The target can be set equal to average of its value for the nearest k neighbors. So that is something which depends. Like we did a Euclidean distance method. Sometimes it could be average, or like the various methods could be there, but largely because we had binary 0 or 1, we went ahead with the Euclidean distance method. The value of k is critical. K that is too large or small will produce high or low biases, or high or low variances. So when your k is too large, very important point, please make a note of it. Or let me just first cover the last point. So Cecilia, to your point, the value of k is often set to equal to square root of the training dataset sample size. So our training dataset sample size was 5. So we took a root of 5, which was around 2 point something, and we chose the k as 3. So if your training data set 400 points, the ideal value for k is 20. You can do a ascend your 20 data points in the ascending order, then you conclude based on the observation. Now this point is very important. Like exam point of view, last the 2 points are important. Like choosing a value of k, and the value of k is critical. K that is too large will produce high bias and low variance. Can you tell me high bias, uh, low variance? Is it overfitting or underfitting? Like just a quick refresher of like I'll keep you brainstorming in
High
between.
bias, low variance is underfitting.
Perfect. Yeah, that's correct. So if your k is too large, if k is too large, you may end up problem of underfitting. When I say underfitting, high bias, low variance, that is your model is quite simple. And when your k is too low, then you end up problem of overfitting, high variance, and low bias. So you need to remember this point from this. That was what I presented on PDF was just for your understanding, to get feel of what this KNN, k nearest neighbor means. But yeah, from exam point of view, these are the two important points that